Hey. Let's say you were browsing the internet the other day and you saw this research paper right there. This research paper said that females smoke as much as males. And you saw that and you got surprised. Like, wow, how can they be the same in terms of smoking? I know that males smoke more than females. And then you look at the date of publishment and it turns out to be 2005, which is very old, right? So you decided to do your own research and prove that males smoke more than females. So what you did is that you had the idea of, well, I want to do a new research in 2026 that will prove that males smoke more than females. So the way that you will do this is you first need to prepare your two hypotheses. Your null hypothesis called H0. The null hypothesis basically means the old ideas that everybody presumes to be true. Like in this case, males smoke the same amount as females. And then you have H1, or sometimes referred to as HA, the alternative hypothesis. It's the hypothesis that you want to prove. It's basically males smoke more than females. So you decided to put the work in and you want to collect your sample. So you visit your city, different neighborhoods, etc., and you manage to collect 1,000 male and 1,000 female. Okay? And you plotted the data. Of course, after the interviews and stuff, you plotted the data in a 2 by 2 table. You put males above here and you put females down there. And of course, the first column is for smokers. It turns out, it turns out in your research that out of the 1,000 males in your sample, 700 males are smokers out of 1,000. Well, on the female side, only 300 smokers are there out of 1,000. So you saw that and you said to yourself, "Well, I told you, bro. That's the right thing. Males smoke more than females." But guess what? That's not enough yet. You still have to apply tests of significance. What are these tests? Because now this result says that males tend to smoke more than females. But guess what? This is the result only for your sample. It's not for the whole population. That that is like the city that you live in, right? So you decided to apply a test of significance. Which one is the test of significance that you will apply here in order to know that these results are right or they are by chance alone? Well, by the way, tests of significance are tests that will measure what's called the p-value. It's a value that if it was very small, okay, when very small, like smaller than or less than 5%, it means that the test is significant and the results are true. And you can actually, by that, you can reject the null hypothesis, which is right there on the left-hand side, and you can accept the new one if the p-value is less than 5%. Let's say you applied the right type of test in this case, and you get a p-value of, let's say, it was 0.01, like 1%, and which is less than 0.05, right? In this case, you can confidently say that my results will apply to the population and they are not due to chance alone. Okay? So the question that we are left with, what is the test that we used in the study? Well, we have to know four types of tests. They are the chi-square, t-test, analysis of the variance, aka ANOVA, and correlation coefficient. These are the most important four. Of course, we have more, but we are going to focus on these four in this lecture. So how can we choose which test is the right one? Well, it depends on your variables. It depends on your variables, your independent variable and the dependent one. The independent variable is the variable that you have before the result of the study. So in this case, we are making a study on smoking, the association between gender and smoking. So the independent variable is going to be your gender, right? And the independent variable, or sorry, or the dependent variable here is going to be your smoking status. Okay? So as you know, gender can either be male or female. Two choices only. Smoking also, you are either a smoker or you are not a smoker. So we are dealing with both categorical variables. In the independent variable, it's either male or female, and in the dependent variable, it's either yes, I'm a smoker or no, I'm not a smoker. So when both of your variables are categorical, they don't accept like numerical values. Um, the test of choice is going to be your chi-square. So chi-square is the choice here. But what if I told you that, let's say I have a different research question, completely different, that says, is there an association between gender and, let's say, mean blood pressure level? So I have the gender is my independent variable, and the mean blood pressure is my dependent variable. Of course, as we discussed earlier, gender can be either male or female, but mean blood pressure, bro, it can take a lot of things. It's not categorical, it's a numerical value. It can take an infinite amount of values. So when you are dealing with this state where you have categorical variable in the independent one and you have a numerical one uh, in the dependent variable, you are dealing with either a t-test or ANOVA, which is analysis of the variance, right? How can we choose though? All you have to do is you have to look at your independent variable. In this case, it's gender. And ask yourself, is my um, variable here, the gender, is it taking two or more than two possibilities? Well, of course, it only takes two. It's male or female. Only two choices. Only two possibilities. In this case, the answer is t-test. But let's say a different research paper says, is there an association between mean blood pressure in cats, dogs, and rabbits, let's say? Now we have three different groups, not only like males and females. No, we have three different. And we are seeing if there is a difference between them in terms of mean blood pressure. In this case, it's going to be analysis of the variance. So see, they are very similar. In t-test and in ANOVA, we are dealing with an independent variable that is categorical. It takes some possibilities, two or more, and a dependent variable that is numerical, quantitative, right? But if the independent variable has only two possibilities, in the case that we have, it's going to be a t-test. If it's three or more, like in cats, dogs, rabbits, etc., it has to be ANOVA, okay? And last but not least, if we are dealing with two variables, okay, that are both quantitative. So if I told you, answer this research question. Is there an association between mean blood glucose level and mean blood pressure level in Texas, for example? Okay. Well, we collect our sample, blah, 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 blah. But bottom line is that we are doing a research and the variables in this research, the independent and the dependent are both quantitative. They take an infinite amount of possibilities. In this case, your answer should be what's called correlation coefficient. It's not t-test, it's not chi-square, it's not ANOVA, it's not anything else. It has to be your correlation coefficient denoted as R. Okay? So these are the most important four, or the four most important tests of significance. They are used to calculate the p-value. And if the p-value is lower than the significance level, which is 5%, if it's lower than that, it means that your study is good. It means that you can reject the old assumptions and you can now have new assumptions. I hope you found this discussion useful. Let me know if you do so, and peace.